Welcome to the Kusto Query Language from Scratch course. In this module, you'll learn 80% of the operators you'll ever use. I'm Robert Kane, and I'll be your host for this course. Now that we've covered the introduction, we're ready to really get started. In this module, we'll cover the most common operators of the Kusto Query language. By the end of this module, you'll be able to write queries to cover a majority of your needs. For your reference, here is a list of the keywords we'll be covering in this module. Each keyword will be placed in a clip of its own for easy reference in the future should you wish to return and refresh yourself on a specific operator. The first command we're going to look at is search. Search works by looking across one or more tables through one or more columns for a specific text string. In this example, I'm taking my perf table, piping it into the search operator, and I'm looking for the specific keyword memory. As I mentioned in the intro, I'm going to be using the Shift-Enter to run things. And as this can take a minute or two to run, we're going to let this execute while I fast forward through time. Okay, we're back. As you can see by the counter over on the right, the query took 1 minute and 2 seconds to execute. If we look down into the results, you can see I have a counter that's virtual shared memory, another one that's used kilobytes. Here's virtual shared memory. So you can see it found the keyword memory within the counter name column. Now, the keyword did not have to be in the counter name. It could have existed in any column in my output of the perf table. It just so happened that they're all within the counter name for this example that we're looking at. All right, let's go take another look, because what I want to mention is that the search is not case sensitive by default. So I'm going to go execute this query, and again, it's going to take a moment to run. The perf table is a pretty big table, so it's got a lot of rows to search through, and additionally, it's got to go through every column that is text-based, and it's got to see if the word memory occurs. So let's go take a hop in time. We'll fast forward, and I'll see you on the other side. Okay, we're back, and what I want you to notice is in the results, we have our object name of memory, and we can scroll down and we'll see memory used in some other places. The object name here clearly has a capital M on the front, yet the search still found it, and that's because by default, it is not case sensitive. But I can hear you go, but Robert, what if I want it to be case sensitive? Well, fortunately, we have a nifty little switch we can add to search. You can see here we've added kind equals case sensitive to my search command. So once again, we'll run this. And now this should find 0 rows. And boom, that was actually pretty fast. 0 records matched for the selected time range. So we're not going to find any matches with a lowercase m in the word memory. Now, we can employ search across multiple tables. If I scroll down here, you can see I can just issue the keyword search and pass in what I want to execute. This is going to search the entire database across every single column. This is a huge search. I actually tried to execute this one time, and after 30 minutes it timed out. So we're not going to try to run this here. I don't recommend you do it either. I just wanted to mention this because it can be done if you have an especially small data set. A better choice is to limit our search to just a couple of different tables. So I'm going to scroll down here, and I'm going to look for the word Contoso in these 3 tables, perf, event, and alert. I also want to show you that I can change the time frame for a search. I can do it within the query, and we'll see how to do that a little later in the course. But I can also come up here to the top, and you can see where I have the drop-down that says last 24 hours. Well, I can change that to multiple values. I can go to last 24, last 2 days. We'll use last 7 days, but we can also limit it to 10 minutes, an hour, and so forth. Or I can actually enter my own custom time range. So I'm going to set this to the last 7 days, and I'm going to execute this. And this is going to go off and run for a minute. So we'll pause the recording a moment and we'll come back when it completes. And we're back. And as you can see, the query took 1 minute and 5 seconds to execute, looking across 7 days worth of data in the 3 tables. If we come down here, you can see it found the word Contoso as part of the computer name. And this can be a very common use for using the search command, is to look for, say, a specific computer that may be having issues, and you want to see if that computer generated anything in the performance metrics table, the event table, or the alerts. So here is all the outputs, and you can see it looks like Contoso Web FE1 was a pretty busy computer. Earlier, when we created our first query, we did perf, and we piped it into search and then gave it the text string. This is actually the same as doing a search in and just passing in one table. So I just wanted to show you that there's no real difference in syntax. Whichever you prefer, you can use. So far, we've been searching the entire table for the particular text string we want. Within a table, though, we can further limit our search to just a specific column. Here I'm taking the perf table, piping it into my search command, and I'm going to specify the column name of counter name. What I'm going to look for is available MBytes, and by using the equal syntax, I'm saying I want you to look for the exact phrase available MBytes inside the counter name column. So let's execute this. And you can now see in my results set, I only have rows where the counter name equals available MBytes. Okay, very cool. Now, what if I want to search for a value that is anywhere in the text? For example, I may not want to look for the exact phrase available MBytes. I just want the word MBytes to be in there somewhere. Well, all I have to do is change my syntax slightly to use a colon. So we're going to run this, and before I forget, I'm going to come back over here and change my time frame back to last 24 hours. And we'll run him. And so now you can see if I come down here to my counter name, I've got available MBytes, but I've also got counters called available MBytes memory, used memory MBytes, available MBytes swap. So I've got lots of different counters that have the phrase MBytes in them. So by switching to a colon, we change the search pattern to say, look for this phrase anywhere in the text of this column. So earlier, I was searching across the columns for a match on the word memory. But I can also search using wildcards. Here you can see I'm taking my perf, passing it into search, and I'm looking for the word bytes anywhere in the column text. So asterisk bytes asterisk says you can be anywhere in there. So we'll execute this. And here we go. Let's come down and take a look at our output. Here we have the counter name, used memory kbytes. And I'm sure if we scroll down far enough, we'll find some MBytes and some other uses of it. Well, that's great. We've got this appearing at the end, but what if I want to only find columns that begin with the word bytes? Well, KQL has a parameter that we can add in here called starts with. So I'm going to search, the asterisk says search across all columns. I'm then going to have the parameter of starts with, and then I'm going to pass in bytes for that parameter. So we'll execute him, and this is going to go search and find only the columns that begin with the word bytes. Okay, so if I come down here, you're going to see we have a counter name, bytes received per second, and bytes sent per second. So it's found the column, in this case, it was the column counter name, that had the keyword bytes at the very beginning. Let's look at one other example, because I may want to find all of the rows who have a column that ends with the word bytes. So I'm going to come over here to this next query, and the only difference is I'm doing a search. The asterisk says search across all columns. I could also search across a specific column, say counter name, by placing it where the asterisk is, but we're going to look for those columns that end with the word bytes. Okay, so here's our results, and we found free megabytes. So free megabytes, available megabytes. So it's returned quite a few rows where we have a column, in this case it's the counter name column, that ends in the word bytes. I want to point out something too. You'll note that the starts with shows up in blue, but ends with shows up in black. That's strictly a user interface issue that the development team's still working on. They don't have it quite where all of these parameters quite show up yet in the correct color, but that's something they're working on. So by the time you see this video, you may be seeing ends with in blue, so don't be tripped up by that. It's something that they're going to work on fixing. Okay, we have another method that we can do wildcard searches. In this case, we're going to search for free asterisk bytes. And what that's going to do for us, it's going to say, hey, I want you to search all of the columns where the text in that column begins with the word free and ends in the word bytes. I don't care what else is in between it. So we're going to go ahead and run this search. And let's go see, we've got our counter name of free megabytes. And that seems to be what we're matching on. Perfect. A common need is to actually combine some of our search logic, and KQL certainly supports that. Here, I'm going to look for the free asterisk bytes, but if you notice down here in my instance name, I've got a C colon, but I've also got underbar total, /var, /lib, /kubelet. I want to only return the instance names that have C colon and D colon in them. So that's what I've done here. I've said search the columns for free asterisk bytes and search for a C colon or a D colon in one of the columns. In this case, it's going to be the instance name, but this just gives you an example. So we'll run this. And here you can see in our results, we've got our free megabytes. And then in our instance names, we've only got C colon and D colon. Perfect. So one last thing I want to show you is that search also supports regular expressions. Here, I'm going to take my performance table, pipe it through search, and in this case, I'm now going to give it a specific column name. And whenever you can do so, you should try to limit it to a specific column name. In the previous examples, I would get much faster result sets if I'd have said search counter name equals free asterisk bytes and instance name equals paren C colon or D colon. So we're going to search here on instance name. Then we're going to use matches regex. And then the regex phrase I'm going to use is bracket A-Z bracket. And in regular expression terminology, that means I'm going to look for any single character in the range of A through Z. And then I've got a colon in there, which is just a hard-coded value. It says any character A through Z followed by a colon. So we'll execute this. Alrighty, so if I come down here to my results, I can scroll through and you can see I have C's and D's. And currently the sample data set from Microsoft just has C's and D's. If I had E's, F's, and G's, they would also show up here in the results. Okay, with that, you are now a search wizard.